Think about a way that a car accident and a game of pool are similar. Did you get it? I'll give you a second to think about it. Both of these are examples of collisions. The cars crash into each other and the balls collide with each other in pool. Collisions can happen around us, also called macroscopic level, or they can happen at a microscopic level. There are 3 types of collisions I will talk about, and those are elastic collisions, inelastic collisions, and perfectly inelastic collisions. Elastic collisions basically occur if the final kinetic energy is equal to the initial kinetic energy. They are collisions in which no kinetic energy is lost in the event of the collision, meaning that the kinetic energy is conserved and so is the momentum. Elastic collisions are not common at macroscopic level, but are found more at microscopic level. An example of this would be the game of pool. The picture on the right explains that when 2 objects collide, they will go in opposite directions with about the same energy they came at if the collision is elastic. Inelastic collisions occur if the final kinetic energy is greater than 0 and less than the initial kinetic energy. They are collisions in which there is a loss of kinetic energy while the momentum is still conserved. Inelastic collisions happen more at macroscopic level than microscopic. One example would be a car crash of 2 differently weighted vehicles. If a truck crashed into a car, that would be an inelastic collision, since the collision would cause the vehicles to move only slightly compared to an elastic collision. This is also shown on the picture on the right. Perfectly inelastic collisions happen if the final kinetic energy is equal to 0. They are collisions in which 2 objects stick together as a result of the collision. Going back to a car accident, if both vehicles are of the same mass and have a head-on collision, the vehicles will stick together after colliding. There will be no energy produced either. Now that we understand collisions and some types of it, let's move on to atomic collisions. Atomic collisions are collisions that happen at atomic level with atoms and molecules. They can be either of the 3 types of collisions that have been talked about. But since elastic collisions mostly happen at microscopic level, that is the type of atomic collision I will be talking about. We know that in elastic collisions both momentum and kinetic energy is conserved, so we can use the conservation of momentum and conservation of kinetic energy equations to solve elastic collisions. This is the law of conservation of momentum, and this is the law of conservation of energy. Here is the key to explain each of the parts of the equation. We can also take the equation for conservation of momentum and derive it to make it easier by removing the masses from both sides and by doing first initial velocity minus the second initial velocity equals to the second final velocity minus the first final velocity. Here is an example question. A helium nucleus of mass 4m collides head-on with a stationary proton of mass m. Show that this is an elastic collision. We can do this by using the conservation of momentum equation. So 4mu plus 0 equals to 4m times 0.6u plus mv. Then mv equals to 4mu minus 2.4mu. Finally, V equals to 1.6u. Then we find the total kinetic energy before the collision, which is half times 4mu squared, which equals to 2mu squared. Then we can find the total kinetic energy after the collision, which equals to half times 4m times 0.6 squared plus half times m times 1.6u squared. Next, 2m times 0.36u squared plus half m times 2.56u squared. Then 0.72mu squared plus 1.28mu squared, which gives you a total of 2mu squared.